Picture a small diner with 3 waiters on a normal night. Then a food blogger posts about it, and suddenly a line wraps around the block. A good manager does 2 smart things at once. A host stands at the door and walks each guest only to a table that is clean and has a waiter ready, never to one where someone just walked off sick. Meanwhile, the manager is on the phone pulling extra waiters off the bench, and when the rush dies down at midnight, sends them home so payroll does not bleed. That host at the door is a load balancer, and the manager adding and cutting staff is auto-scaling. And together they are how a cloud app survives a traffic spike. Real traffic is spiky and unpredictable. A flash sale, a viral post, or a morning rush can multiply load in minutes. If you provision for the peak, you pay for idle servers most of the day. If you provision for the average, the spike crashes you. You need a system that detects rising load, adds capacity fast, sends users only to healthy servers, and removes the extra capacity when the wave passes. 2 services work together. A load balancer is the single front door that distributes incoming requests across a pool of backend servers and stops routing to any that fail a health check. An auto-scaling group manages the pool itself, launching and terminating EC2 instances to keep a chosen metric on target. The load balancer handles where each request goes right now, and the auto-scaling group handles how many servers exist. Together, they give elasticity, capacity that tracks demand. Users resolve your domain to the load balancer's DNS name, so every request enters through it, not through any individual server. The load balancer forwards each request to an instance in its target group, the live list of backend servers, spreading load with an algorithm like round-robin or least outstanding requests. The balancer health checks each target every few seconds, and any instance that fails is pulled from rotation until it recovers, so crashed servers get 0 traffic. CloudWatch collects metrics from the group every minute, such as average CPU or request count per target. A target tracking scaling policy compares the metric to its goal. For example, keep average CPU at 50% and computes how many instances are needed. When demand rises, the auto-scaling group launches new instances from a launch template, which defines the AMI, instance type, and config, and each new instance takes 1 to 3 minutes to boot and pass health checks. Once a new instance is healthy, the load balancer registers it and begins sending it traffic, lowering the average load per server. After the spike, the metric falls below target, and the group terminates surplus instances following a cooldown period that prevents rapid flapping up and down. An online store runs a steady 3 instances at min size, with max set to 30 and a target of 50% CPU. A celebrity tweets a discount code at noon. Within 2 minutes, CPU on every instance hits 95%. CloudWatch reports the breach, and the auto-scaling group begins launching instances in batches. Each takes about 90 seconds to boot, install the app via the launch template, and pass the load balancer health check, after which it starts taking requests. The group climbs toward 20 instances, average CPU settles back to 50%, and no shopper sees an error. By 1 p.m. the rush fades, CPU drops to 20%, and after the cooldown the group scales back to 3, so the bill returns to baseline. A frequent error is expecting scaling to be instant. New EC2 instances need boot and health check time, often 1 to 3 minutes, so for sharp spikes you set a sensible minimum, use warm pools, or scale on a leading metric like request count rather than lagging CPU. People also confuse the 2 services. The load balancer does not create servers, it only routes among existing ones. And the auto-scaling group does not route requests, it only changes the count. Another mistake is forgetting health checks, which means a hung server keeps receiving and dropping traffic. It is the host and the manager working as a team. The load balancer routes each request only to healthy servers, while the auto-scaling group watches a metric and launches or terminates EC2 instances to keep capacity matched to demand. Every day, I dissect one cloud architecture down to its real moving parts. So subscribe to TechWithJoel and build systems that never fall over. What is the biggest traffic spike your app has ever taken? Subscribe to TechWithJoel.